S. Chand presents educational video lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
So now in part 2 we'll be covering directional derivatives. In part 1 we have done curl and divergence of a vector field. Hello everyone, I am Dr. Seema Thakran. Welcome to S. Chand Academy. For engineering mathematics, please refer to the book by S. Chand Publishing. The ebook link is given in the description box below. So let's start with the directional derivatives. So for directional derivatives, as the name suggests, directional derivatives, it means the derivative in particular direction. Derivative means rate of change. It means rate of change particularly in one direction and it will be given. So directional derivatives. For directional derivatives, what basically we should have, first is phi, that is scalar field. Scalar field means it has no ijk, there is no component in ijk direction, it's just without ijk. So that is one scalar field, and one is direction. Directional, one direction you will be given and it should be a unit vector. So the one scalar field you need and one direction you need to find directional derivative. The formula for directional derivative is directional derivative of scalar field phi in the direction, this is how you write it, in the direction of A is given by del phi dot A, and finally I'll make it unit vector, so I just write this cap. Cap means this is unit vector. If I'm just putting normal arrow, it means that is vector, but if I'm putting a cap, it means this should be unit vector, and if it is not, I'll make it unit. And this del phi is also a vector. Del phi, we have already, if you recall in my very first lecture where I discussed gradient phi, so this is basically gradient phi. So refer to that lecture if you want to understand more about gradient and what exactly gradient means. So gradient phi, if you multiply, if you take the dot product of the directional, the vector, unit vector, in which you want to know the directional derivative, just simply multiply del phi dot A. So I am taking one quick question to understand. So question is, find the directional derivative of phi, that is, this is my phi, this is 3x square y z square, this is scalar field you can see. So find the directional derivative of phi in the direction of 3i minus j plus 2k. So this is the question. How you will find? As per the formula, solution. We know that directional derivative of phi in the direction, and I just call this vector as A vector. So right now it is not unit vector, so I'll write only arrow, I'm not putting a cap, in the direction is given by, so what is the formula? Del phi dot A, I'll make it unit. Now del phi, how we find out del phi? So first I calculate del phi Then I make this vector unit vector. I take the dot product. I'll get my directional derivative. So del phi. Del definition is del by del x I, del by del y j plus del by del z k, and phi. Phi is 3x square y z square. It means this is gradient anyhow. So these all three operators will operate on this del by del x of this, then del by del y, and this. So del by del x of the phi, that is 3x square y z square I component. And you can even notice curl was a vector, divergence ultimately was not a vector, gradient phi is also a vector. If you notice this is a vector. Now del by del y of 3x square y z square j plus del by del z of 3x square y z square k. Differentiate and write del phi. When you will differentiate it with respect to x, what will be the answer? It will be 6x y z square I, then y, so it will be 3x square z square j, and with respect to z, it will be 6x square y z k. So this is my del phi. What was my a? A was 3I minus j plus 2k. So 3I minus j plus 2k. I'll make it now unit vector. Before taking the dot product, I'll make it unit vector. So to make unit vector, just divide it by magnitude, and magnitude formula is, what do you do? Under the root I component square 3 square, j component square 1 square, k component square. It means finally my vector is 3I minus j plus 2k. So it is 9, 10 and 14. So this is now finally my unit vector. Multiply it by this. So del phi dot A will be 6x square, because this is dot product. So finally, when you will just take the dot product with this vector, it will come out to be 6xy component wise product 3 by under root 14. This component 3 by under root 14 into this component, the I components. Because I dot I, we know I dot I is 1. That's why 6xyz square into this plus 3x square z square into minus 1 by 14 under root 14 plus the final 6x square y z into 3 by under root 14. So this is my directional derivative. Sometimes in the question you get in addition that particularly at this point you find the directional derivative. That part also I am adding. So I am just adding or extending the question. Find the directional derivative of phi in direction of A, yani in particular direction, at point 1, 0, 1. What to do now? Just in place of x, replace x by 1, y by 0 and z by 1 in the final answer. So if I just replace x, y, z, y by 0, it means this will be 0 finally, because y, we have y here, and this will be x, z, 1. So the final answer in this case will be del phi dot A. So my answer will be minus 3 by under root 14, and this is again has y, so this is the answer. So it means this is the directional derivative at that particular point. This is how we find out. Now next, I am just changing the question pattern. Question is, find the directional derivative of phi, and that is 3xyz in the direction of AB, where A is 1, 0, 1 and B is 1, minus 1, 0. So this time there is a change. It is in the direction of AB. So what exactly AB? How you find AB vector? Just simply subtract B minus A. You will get your AB vector. So it means 1, minus 1, 0. Minus 1, minus 0, minus 1 and 0, minus 1, that is, this is your AB vector. You can write this in this form also. It totally like however you are comfortable. So both are the ways to write AB vector. So 0 into I minus j minus k. Now phi is this and this is my, I just make it in advance unit vector also to save the time. So this, now I am making it a unit vector. So I am putting a cap. So this will be minus j minus k upon under the root, there is no I component, so j component square plus k component square. So finally this is my unit vector. Just multiply it by del phi, I'll get my directional derivative in particular in this case. So del phi, you can write in, you can do it in one line also. So del by del x of 3xyz, then del by del y of 3xyz j plus del by del z of 3xyz k. This is my del phi. Directly I have written it into dot with the unit vector minus j minus k by under root 2. If you are differentiating it with respect to x, it will be 3yz. Then it will be 3xz j and it will be, there is no minus sign, so this will be 3xyk and dot with minus j minus k and under root 2. There is no I component in this, you can see 0. So it means 0 into this will be 0. Then j component, this is minus 1 by under root 2 and into this. So minus 3xz upon under root 2 minus 3xy upon under root 2. This is the answer. So this is how you find the directional derivative, and the type of questions we did, this how you get the questions in your exam, or you are like if you are giving any competitive exam. So this is all about directional derivative. Directional derivative is basically the gradient phi of one scalar function you will be given, and you will find the gradient and you will multiply the gradient phi with the particular direction, and the directional vector should be the direction, the vector which is given in the direction should be unit vector, and take the dot product to find the directional derivative. For engineering mathematics, please refer to the book by S. Chand Publishing. The book is very good and you find the concepts very easy explanation for the questions, for the theorems, for the concepts. So please refer to the book by S. Chand Publishing. The ebook link is given in the description box below. Please like, share and subscribe S. Chand Academy. Don't forget to press the bell icon for the future updates. Stay connected, stay tuned, keep watching the upcoming videos. Thank you.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.